all know that animation is a crucial part of the user experience for both web, native, and any other visual medium that we could have. I studied piano in university, and music is basically animation expressed through sound and not through visual arts. And there's so many animation libraries nowadays that focus on animation from point A to point B, having a start and an end. But what about animations that basically have no timeline, no fixed timeline? I'm talking about animations that can respond to user input or any other external input or even other animations. So that's what I'm going to talk to you about today, and hopefully learn a little bit of RxJS if you're not familiar. My name's David Khourshid, and I work for Microsoft. Recently, we launched Project Glimpse. This has nothing to do with animation, but I sort of sneaked in a couple little animations into this app anyway. If you work on Node and Express, I highly encourage you to check this out. This is something that you add to your Node and Express apps, and it allows debugging and diagnostics into your full Express application. So check it out at node.getglimpse.com. Shameless plug. So anyway, as they said, I am a pianist, I promise, and I have a dog. It's a very special dog. And I live in Florida, which is right here. Just for the geographically challenged, Sweden is way the fuck over there, which I'm really glad to be in Sweden, because we have a little problem. That's Hurricane Irma. And hurricanes are notoriously difficult to track because they're big, huge, dangerous things that, you could think of a hurricane as a continuous sequence of events of rain, wind, thunder, and just utter destruction. And so we measure it using satellites, using radar, and by flying reconnaissance airplanes into the eye of the hurricane every 3 hours. This means that we, Floridians, we get advisories every 3 hours. And based on each of those advisories, we have a different reaction because the path of the hurricane updates. And so, so now the path of Hurricane Irma is headed directly to my city, Orlando, Florida. It's right in the middle of the state, but it's still going to get the hurricane. And ironically, it's coming in just as I'm supposed to fly in. So, thankfully, I have a place to stay. I called them. They said that they have plenty of beds. So I'm like, perfect. Okay, so what are reactive animations? You might be thinking, does it have anything to do with React? Isn't it just like a normal animation? Here's how it was defined in 1997. A reactive animation is one that involves discrete changes due to events. And these events could be continuous events. So by discrete, we mean things that can exactly be measured, and continuous, just the more you try to measure it, the more infinite you realize the data you're trying to measure becomes. But one of the useful things in this paper that was said was that by allowing programmers to express the what of an animation, one can hope to automate the how. And so you might be thinking, this is declarative, and that's true. So this original paper discussed ideas of creating declarative, reactive, and functional animations. And so he called it FRAN. FRAN was the basis for RxJS and ReactiveX and all of these other, the concept of functional reactive programming. So why do we want to make reactive animations? Well, if you look at the top apps, you look at just anything that is on the App Store that has any sort of popularity, you're going to notice that a great deal of focus has been placed on the actual animations inside the app. And this is to capture user attention and to make the user more engaged with the product. So these are extremely good things to focus on. But before we get into the actual reactive part, I sort of want to explain to you what type of data structure we're going to be dealing with. So in JavaScript, we have a value, which I'm just representing as a ball. Now, a value could be like a string or a number, or an object, just any single fixed value. But now let's add time into the mix. Tomasz gave a really good talk yesterday about just the different ways we handle async, and promises were one of them. So a promise can be considered a single value over time. Now, of course, we have this idea of multiple values, and that's arrays. And all of these values occur at once. An observable, which is what we're going to be dealing with, can be thought of as an array because it's essentially a collection of values that happen over time, just like a promise. So consider the idea of promises where things happen asynchronously and apply it to multiple values, and you get an observable. Sometimes I like to refer to them as streams because it's a little bit more approachable that way. So an observable can be considered a collection of values that happens over time, and observables are immutable, which means that you could subscribe to the observable emitting each value, but you can never go back and change the value. It's just like time. You can't go back to the past and change time. Otherwise, we would have done so in November in the United States. But I shouldn't have said that. Anyway, observables can do one of three things. They can complete, which means the observable is done emitting values. They can be indefinite, which means the observable is going to keep emitting values, and you're never going to know when it's going to stop, or an error can occur. And that's sort of the same as an observable completing, but instead of a completion, it's an error. Now, one of the most popular implementations of observables is known as RxJS, which is an implementation in JavaScript of Reactive. In order to get it, just npm install RxJS, save it because you're going to want to keep it, and then import Rx from RxJS. Creating an observable is also, I don't want to use the word straightforward. It's a bit of a learning curve. I'm going to be honest with you. So what happens is you pass in a function which takes in an observer, and this observer has three methods: next, error, and complete. For simplicity, we're just going to use the next method. So let's say we wanted an observable that only emits every second, right? So we set an interval, and on each interval, we just pass a null value. And so that's going to emit every 1,000 milliseconds. Now, this observable, we also return something to clean up the observable, and that's clear interval, of course. The beauty about RxJS is that there's operators for pretty much almost anything. So all that just becomes this: rx.observable.interval 1,000, and then you have that observable of values every second. So you could create an observable from an event, such as whenever you move your mouse on the document body, you could capture that mouse move event, and then all of a sudden, you have an observable, which you could think of as an asynchronous array of mouse move events. And then, just like arrays, you could map over those mouse moves and get the x and y values, which is client x and client y. Okay. So example time. Over here, I have this range observable, and this range observable is going to get input events from the range, and we map that to the value of it. So in this case, we have either 6, 5, 4, or 3 rooms. And so whenever we get a new value, we're going to call this update function. And all that does is set some attributes. And then we could see that, it changes. And of course, you might be thinking, well, yeah, but I could do this with a normal event listener, right? Yes, but we're going to be talking about the advantages of doing it this way later on, especially for more complex applications. For example, you could create an observable which is the same type of thing from an event pattern. And so this is not a strict DOM event or browser event, but this comes from anywhere. So Hammer.js is a library for handling touch input, and we could use that to detect whether we're panning left or panning right. You could also do things like zooming and scrolling and other stuff. And then we could just pass in a callback. I call it handler over here, so that whenever we pan left or pan right, that handler is what emits the value. And then from that, we could map each one of those events and again, get the delta x and delta y. So that's why Hammer is such a cool library, because it just gives you those values. So here's an example of that. I'm doing 2 observables here. I have this pan where I use Hammer, and so I'm detecting pan left, pan right, and pan end, which is when I take my finger off. And I'm also detecting whenever I take my finger off, I want this physics library, Dynamics.js, to sort of spring it back to position. And so using observables, it works out in a very straightforward way. And it's also declarative, because we're not doing anything until this subscribe method down here. So these observables don't even start listening until we call subscribe on them. So they're lazy by default, just like me. Speaking of lazy, come on. All right, so as I said, there's a lot of operators in RxJS, and you might be familiar with a lot of them right off the bat, such as map. You map over an array, you're going to get the same type of result from observables. Filter works the same way as well. So over here, we're just getting all of the yellow balls. Now, observables, since they're async arrays, we could also have time operators too. And so in this case, every item that we got, we delayed it by 100 milliseconds. Now, you might be familiar with array.reduce. We have a scan operator, which sort of does reduce, but for intermediate values. So to exemplify this, over here I have an observable of just numbers, and then scan is going to take the last number and the current number, add them together, and then that's the next value. And of course, we start with 0. So 1 plus 0 is 1, 1 plus 1 is 2, and so on. If you know Redux, this is a very, very useful operator to have, because that's Redux in one line of code, one line of RxJS. Observables too can be merged together. So we could compose observables from other observables. In this case, we have 2 different observables, and we could merge them into one just by combining their events together. We're going to see how that's useful in a minute. These are called marble diagrams, these arrows with the marbles, and there's 2 very useful sites that I like to go to for visualizing them. One is rxmarbles.com, which has been around for, I think, a year or 2. And then one new one is called rxviz.com, where you could actually input observables and see them live. And so you could create your own, whereas rxmarbles is fixed. Honestly, if I were to name them, I would have called them Observables, but. So given that, I want to make it clear that animations are a function of state and time. So sort of like Redux, or representing your UI as a function of state and an action, you get a new state. Same thing with animations, where it's a combination of time and actions. So given the current state and given time and potentially other actions, you get a new state. By thinking of animations this way, we could approach animations in a functional way. Now, there are many libraries for creating animations that sort of allow you to do it imperatively in an easy way, but it's not really scalable, not really composable, and definitely not testable. I mean, how many of you actually write unit tests for animations? No one's hand went up. Great. So let's actually try to create something. Here's what I want to do. I want to do sort of an Apple TV effect with these goats. So So the first thing I'm going to do is I'm going to get the mouse position. And so I see that I got that. All I did was get the from event, mouse moves, and I mapped over it, getting the client X and client Y. The next thing I want to do is take those X and Y positions and rotate the goats so that they face the mouse. And so we see that we do that. And so these are two operators that we already learned, from event and map. Now, you could be saying, we're done here. This looks great. I'm not satisfied quite yet, and here's why. This is a cool effect for a computer, but a lot of people, they look at pictures of goats on their tablet as well. And so in order to get the same effect, we want to merge both mouse moves and touch moves as well. And so we're doing that over here. We're getting another stream of touch moves from the document, and then we could just combine the two and merge them just like so. And that way, we get goats that respond to both mouse moves and touch moves, just by doing a single merge command. Now, I'm still not satisfied. I sort of want a smoother animation because, as you could see, the goats, they sort of stop. So like whenever you're done moving your mouse, it just stops. And so that's not really a natural animation. So in order to remedy that, we're going to be using animation frames, such as request animation frame. Now the way to do that in RxJS is a little bit interesting. We have, of course, rx.observable.interval. If we set that to 0, you could consider that like an infinite amount of ticks, right? Just infinitesimally small, or at least as fast as the browser can do it. But we want to schedule each of these intervals to only occur on animation frames. So you could think of rx.scheduler.animationFrame as just a scheduler that says, all right, all of you in line, I'm going to only allow you to come through every 16.667 milliseconds. And so we're going to be using a new operator too, which is this with latest from. Now this is going into a little bit more advanced RxJS, so I don't expect you to fully memorize this or anything, but just be aware that something like this exists. So with latest from, all we do is we take all of those animation frame ticks, and it's going to carry the latest emitted values from whatever observable you passed in. And then you combine them using a function. So here's a visual way of how that works. If you think of the top as the animation frames and the bottom as the combined observable, then the top one is going to be carrying the latest observable values from the second observable. I don't expect this to make sense, just know that it works. Okay, so we're doing this so that we could do what's called linear interpolation. And again, this is a little bit confusing. I don't like showing like tons of code on the screen, so I'll try to explain this visually. Let's say we have two values, right? 200 and 300. You could consider this x and y values. Instead of it jumping from 200 to 300, I want it to smoothly go from 200 and then arrive at 300 eventually. To do that, first let's calculate the distance, which is 100. Then I have this ratio of 0.1 where I'm saying I want to take a tenth of that distance. And then using that tenth of the distance, which is just 10, I want to move the current position closer to the next position using only, that 10. And so we get that. Now, if we play with the ratios, we could see how this works to get it to smoothly go from point A to point B. The lower the ratio, the longer time it's going to take, to get from point A to point B. And so if we use scan and we pass this lerp function in, or linear interpolation, then we could see that instead of jumping from 1 to 2 to 3, it smoothly goes to the next value. And this is exactly what we want for a smooth animation. So we combine it with laced from, and we use lerp, so just like a redux reducer. We take the previous value and the next value, calculate the deltas, and use that to bring it closer and closer to the next point. And then with that one line, we get this. So as you could see, it's a lot smoother, and I could even, let's make this smaller. Wow, now it's really, really smooth. So these are some smooth goats. All right. And so this isn't just limited to movement. This is a really cool demo by Lizzie Linhart, where when you move your mouse, the emitted values are then converted to colors. And so by moving your mouse, this chameleon whale changes color. And what's awesome is this is using a library that I created about a year ago called RxJS. It's just a very tiny utility library. I don't care if you use it, don't worry. I won't be offended if you don't. But what it does is you could use observables that you create in RxJS, and you could pass the values into CSS variables. Where if you're not familiar, this is just a way of communicating with CSS through JavaScript. So you could literally set these values in JavaScript, and CSS will pick it up depending on where you set the value, and you could use it directly in your CSS. So this isn't JS and CSS. This is just a medium of communication between JavaScript and CSS. And so the idea is that we take a stream of values, and instead of applying those values directly to the elements, we sort of abstract them into these custom properties, and then we could use those however we want. Okay. So here's another example. This is using RxJS and Hammer.js. I didn't do this. This was done by Varun Vashar, and he actually has a really good article explaining how this works. But it's just a simple drag and drop. But as you can see, we have the smooth animation, the linear interpolation, so that it smoothly moves from point A to point B. And furthermore, there's this notion of keeping state, where this element is either being dragged or not being dragged. So we have two different states. And of course, you could represent those states in sort of a reduxy reducer fashion, where you take the previous state and an action, such as drag start or drag end, and you get the next state. Okay. And so a more advanced scenario of this is in this, where I recreated a dribble that I really liked. And this has 3 states, actually. Here, that's 1, 2, and 3 over here. And so this is also using RxJS to do a bunch of things. First, it's keeping the state of whether we're in this navigation mode, this large nav mode, and the small nav mode. And it's also handling the animations as well, in order to smoothly animate from section to section, and also from state to state. And so thinking this way makes you start to think a little bit more declaratively about how you do everything in your UI, whether it's animations or whether it's states. And so over here I have a state machine where I have 3 states, start, nav1, and nav2. And then I have a mapping of actions to next states. And so if I do a pan up action when I'm in the start state, I'm going to go to nav1. And if I do a pan up action nav1, I'm going to go to nav2. What this means is that when I'm in nav2 and I do pan up, nothing's going to happen. Actually, that was a bug you just saw. Pretend you didn't see that. But that's another one. So, so yeah. Now you might be thinking still, why animate with observables? I mean, you might be thinking these animations are really cool, but I could just stuff a bunch of code in events handlers, or I could go to my comfy imperative programming, whatever. But there's a few reasons. 3 in particular. Reactive animations using RxJS or using observables, or just this idea of functional reactive programming, is declarative. Instead of saying, do this, do that, go there, go to there in 3 seconds or so, we can say what we expect. For example, we could say, you are an observable of mouse movements or touch movements, and this is a mapping of those mouse movements to coordinates, and this is an interpolation from coordinates to smoother coordinates. They're also composable, so you could make an observable out of just about anything, including promises, arrays, single values, or there's even rx.observable.never, which doesn't emit any values. It's pretty useless. I never use it. And so you could compose these observables together and react to just about anything, including other observables, which means animations can react to other animations, and then you get these really complex animations. They're also immutable because these 3 things form, just functional programming principles. And this way you could actually, you could test the animations, because you're just testing observables. And there's a ton of good resources on testing observables, especially in RxJS, but now this gives you the power to test animations, to assert that when I do an animation from here to there, it's going to do exactly what I want, and it's going to be exactly where I want it to be. Also, ReactiveX is not a framework. It's not like React, Angular, or Vue. Instead, you could use RxJS in coordination with any of these frameworks and more. I know Angular.io, or whatever it's called, uses it by default, and there's also integration with Vue and React. And lots of people have been using RxJS with all of these frameworks too. Furthermore, there's implementations in all of these languages. So the really cool thing is that you could use RxJS, and what you learn from there, almost the same API, you could apply it to any of these other languages, because ReactiveX is pretty much a standard. It's a community standard. It's not an official standard, but it is a standard nonetheless. Also, there's a library that you might not have heard of. It's called Material Motion, and it's something that some really awesome people at Google are working very hard on, and it's using the notion of observables to actually enable designers and developers to communicate in the same language for creating reactive animations. And so whether you're doing work on iOS, Android, or the web, the amount of handoff time between designers and developers is now cut, because instead of designers prototyping, since it's a declarative approach, designers could essentially code the animations, and the developers could just tweak it a little bit and implement it into the applications. And so I really encourage you to check this out. There's some exciting stuff coming out. I think iOS is already version 1. Android and web are in the works, so look for that coming soon. Really cutting edge stuff. So I want to thank you and leave you with all of these resources. I'm going to put the slides up. If you take one of 2 things from this talk, it's either do reactive animations in your app, or just learn RxJS, because you could do a lot of really cool things with it. Thank you very much.
Thank you.